Welcome to the programming portion of this. I guess we can call it an informational seminar about everything the robotics team does. So, first, robotics programming. It's the most important team, obviously.
I'd like
Uh,
to contest that.
Lies.
First off, what language do we use for programming? Now, first offers a multitude of options that range from using no language at all, something similar to drag and drop coding, to the language that we use, which is Java, which could be considered more of the intermediate to advanced one. And then first offers also another language, which is much more complicated that we're not going to get into. So we use a programming language called Java. Now, what is Java? Java is essentially set almost like a grammatical structure for writing code, right? So it is a class-based programming language. Everything is written in chunks of information called classes. And when let's say you're programming the drivetrain of the robot, everything that has to do with that drivetrain is going to be written in a class that is everything to do with the drivetrain. So when you want to set the drivetrain to go forwards, you're going to say, okay, this chunk of code, I want this chunk of code to, you basically, in your program, you say, run this chunk of code. And that chunk of code is going to be within that class, and that chunk of code is going to set that speed for that drivetrain. Now, next item on the list, Java is an object-oriented programming language. What does that mean? Essentially, everything in Java is an object, and it's the same definition of object that you would use in real life. Every time you say, let's use the example of the drivetrain. When you want to tell the drivetrain you do something, you can create an object called the drivetrain, and then you would tell that object, hey, drivetrain, do this. And essentially, obviously it's a bit more complex when you actually get into it, but that's how the essential organization works inside of Java. Now, Java, it has as few implementable dependencies as possible. Now, that might sound really complicated, but basically what that means is everything's built into Java. You need to do very little to get started programming. Everything, all the mathematics operations, everything you might need, already there. It's very simple. Now, Java is a general purpose programming language, and programming language, and what's very cool about it is that you can write Java code and you can run it on almost any device. Because unlike a lot of other coding languages, like let's, for example, say Python. A lot of people are familiar with Python. Python is it's transcribed directly, and it's what's it called? It's refactored, and it's run. Java is compiled to bytecode, and it runs inside of a virtual machine. That means that any platform, any device, your phone, your computer, anything that can run that virtual machine can run any Java code, which makes it a lot more compatible. So in the next slides we'll get into, you can see that no matter what device you have, you can pretty much be part of the programming team if you have interest in it. So what software do we use for programming? First, we're going to go over the IDE. The IDE is essentially, in the most basic of terms, a text editor. But in reality, it's a lot more than that. So we use a piece of software called Visual Studio Code. So Visual Studio Code, it's a free source code editor, or code editor. It essentially means the same thing. And it's made by Microsoft, and it's available for Windows, Linux, and Mac. So if you have any of those, you can work on the code if you're on the programming team. Now, what can we do with Visual Studio Code? Obviously, we can, just write code. Works identical to a text editor, but it also has more features. First feature it has is something called debugging. Essentially, not only can we write the code, but we can then run the code without having to have the robot with us. And we can identify any issues that may arise when we run that code without having to run it on the robot, which could be dangerous or could cause the robot to malfunction. The next feature is something called syntax highlighting. And that is very similar to like something like Grammarly or autocorrect on your phone, where, if we type something incorrectly or if something seems wrong, it's going to highlight it and it will suggest fixes. It's like, let's say you misspell something. It's going to say, oh, did you mean to say this? It's very similar to something like Grammarly. And then that kind of also covers the second bullet point, which is intelligent code completion. The next bullet point, code refactoring. Essentially, again, it's a very neat feature where you tell the program, okay, refactor my code, and it organizes it and it makes it extremely pretty. So the next person that comes along that's reading it gets something extremely readable. So all the formatting is the same, the indents and the spaces, it makes it look very nice. The next feature is something called embedded Git. And this is something that we're going to discuss in the next few slides, something called GitHub, which is how we share code with each other. So Visual Studio Code actually has embedded GitHub within it, which makes it a lot easier to share code. And of course, it's a lot more complex than a simple something like Notepad or a simple word editor, and you can change the theme, keyboard shortcuts, preferences, and the most important part for us is that you can install extensions. And in robotics, programming more specifically, we use an extension called WPI Lib Suite. What is WPI Lib Suite? So here's just a little blurb from their site. The WPI Lib mission is to enable FIRST robotics teams focus on writing game-specific software rather than focusing on hardware details. Raise the floor, don't lower the ceiling. WPI Lib Suite works to enable teams with limited programming knowledge and/or experience to be as successful as possible while not hampering the abilities of teams with more advanced programming capabilities. WPI Lib Suite supports kits of parts, control system components directly in the library. So when we want to say, let's use the example of make the robot move. We don't have to write extremely complex code that interacts directly with the controllers to say, apply this much voltage, do this, do that. We just say, robot move, here's a value between 0 and 100 to define how fast we want the motor to spin. And it makes it a lot easier for us to program the robot. Now, of course, if we want to set something very specific, we also have that option open to us. And as you see here, WPI Lib also works with Java, C++, and NI's LabVIEW, and those are the three options that I discussed on how we are able to program. Now, we use Java in this instance, but it's compatible with all three. Okay. So next piece of software that we use is something called GitHub, and we use it for code management and sharing. It's very similar to something like Google Drive. So GitHub, it is a software development and version control platform. So the same way when in a Google Doc, let's say your friend goes in there and does a stupid edit, inserts a GIF instead of, your 4-page essay that you've been working on for 2 weeks. You can go in and you can say, okay, I want to delete this version. And you can remove that version. And, the next thing is source control management or source code management. It's very similar to that first bullet point, but essentially you can manage very in-depth what is in your code, and you can even edit directly from GitHub in some circumstances. Access control. So we can control, or me and Nix more specifically, can control what parts of the code you can edit. So you can't go in and make a change that might hamper the robot's abilities, right? Now, of course, no one's going to do that, but in a more corporate environment, this is a really useful feature. The next feature is something called bug tracking. Essentially, a bug is an error in the code. So when me or you or someone finds an error, they can make something called an issue. And they can basically say, here, when I did this with the robot, this happened. It didn't work. And someone on the programming team can go through and see, oh, this issue happened, see where it happened in the code, see the description of the issue, and then they can respond. It's almost like a messaging platform. And they can make the changes and then close that issue. The next major point, so this kind of fits in with feature requests as well. You can do the same thing where we're not necessarily going to be using this feature because we have a much smaller programming team, but in larger companies, they also use this for feature requests. So if someone wants to, I don't know, let's say be able to change colors of LEDs that are attached to the robot, they might make a feature request, and they don't necessarily know how to do that, but someone on the programming team will go in and say, oh, okay, someone requested this feature, let me go and add it. And that also kind of fits into the next bullet, task management. Those in the GitHub share that have the permissions, they can assign tasks to other people. So, instead of you having to go in and, you're just not really sure what you want to do, go in and find an issue to work on, I can say go and, please fix this or add this feature. So that's also a really, useful feature within GitHub. Now, the final feature within GitHub that, is something we might actually use more so than the last few features I've talked about is something called a wiki. And it is exactly what it sounds like. It's essentially a Wikipedia-like page that we can create when you go to our GitHub share, and it's publicly available. It'll essentially be like a Wikipedia-like page that describes what our code is, how to use it, and stuff like that. And it's all publicly available and hosted for free on GitHub. So that's about it. That was the entire meeting. See everyone Saturday at 2:30 p.m. And if there are any questions, you can ask now. I know that was a little long-winded and more complex, but
Make sure that you guys get the thing signed. Like I said, I put the due date on Sunday, I believe. I'm not gonna remind once Sunday finishes, and we're just gonna move on from there. So, yeah, just make sure everything is done by then at least. Yeah, I don't think we have anything else, right? All right. Well, tomorrow we have a meeting. It's programming as well. 2:30. So yeah, I guess we'll see everyone then.